please again allow me to introduce Professor Carlo Batini from University of Milano Bicocca. I think some of our students here followed the summer course with you a few months ago, so they were really very happy about your topics. Carlo is a figure, let's say, in the database community. So he worked with the database semantics and database integration, right? And, so please. Sorry, Carlo, to interrupt you. Can we please stop at 15:50? So after 20 minutes? No?
Yes, no.
Because we have.
Okay, as Mustafa said this morning, my main research area is databases, and I would add information systems and also e-government issues. But with the help of these colleagues, Andrea Marino, Matteo Carbonari, Gianluigi Viscusi, Peria, and Benita, we extended our research areas. And so I can say that we now make research on ontology quality management, on methodologies for service design, on representation and integration of lightweight ontologies in the large, on representation and access to repositories of government services, and on service semantic matchmaking. During my talk, I will dedicate just one slide to methodologies for service design, and the rest of my presentation on the main issue of my talk. Concerning e-government initiatives, we have written several papers, and in 2010 I published, together with Gianluigi Viscusi, a book with Springer on information systems for e-government that deals with quality of service, the governance of data under different perspectives. Now, moving to the main part of my talk, we started to work in these issues related to quality of data or conceptual schemas or ontologies about 10 years ago. And in 2006 we have produced another book with Springer on data quality. We have written several papers on journals. So I made 3 different tutorials. And all this stuff of research has been dedicated to the issue of data quality dimensions, models, methodologies, and techniques. When I speak of data quality dimensions, these are all the dimensions that are mentioned in the most relevant methodologies. There is a huge amount of different dimensions that are related to data quality. The most important of them are accuracy, currency, consistency, and completeness. The main issue we have dealt with as long as 2006 is described in this slide: methodologies for data quality assessment and improvement of a set of databases managed by a single or a set of organizations. Here the most important words are methodologies, data quality assessment and improvement, databases and organizations. Now we have moved from this particular type of research related to data quality in several directions. First of all, from data quality to quality and its relationship with the value of data and information. The second direction is moving from methodologies to techniques, especially in the field of record linkage or entity identification. The third area is moving from generic data quality dimension to specific important data quality dimensions related to time. The fourth direction, from data quality in databases to quality of data in the web, and especially linked data, that has been mentioned before. Then, from traditional data quality techniques to web-oriented techniques, and especially using crowdsourcing techniques for record linkage. Another direction, from quality of data and conceptual schemas to quality of ontologies. and finally moving from flat data in relational tables to hierarchical, or as they are mentioned in the Sierra proposal, spatial data. Now we will go in more detail concerning these 5 issues. And first of all, we see our research in the area of techniques for record linkage concerning using mainly the temporal dimension. Look at these 3 records. This is a real example, one that represents the same legal entity, juridical entity, the same company in 3 of the most important registries on companies in Italy, Chambers of Commerce, Accident Insurance, and Social Security. You see that they are represented the same attributes, ID, type of activity, city, name, and address, but with completely different values. Now we can try to understand if they represent the same company or different companies, for instance, looking at names, and looking mainly in traditional techniques on text distance between the strings that represent names, or an improvement is considered the word distance inside the name of the company, the words that are in common. More sophisticated techniques could be to compare more than one property, for instance, type of activity, but if you look at the type of activities in the 3 cases, they are completely different, so they are of no help for us. Another issue that is very similar to record linkage is the so-called deduplication, in which you compare, look at records in the same table in order to find which are the different records that pertain to the same entity of the real world. Okay, this example allows me to show an improvement of technique for record comparison. In traditional terms, we use the edit distance that I mentioned, that I showed also before, and we obtain that the red tuples are considered to match, and so to represent the same entity. The same for the yellow tuples, and the same for the blue tuples. We obtain this result, as I said, comparing the strings that concern the first name and the second name of the person. But if we know that such persons are senior citizens in the United States, and during the summer and during the winter they change their residence, and so typically what happens is that residents in Florida in the winter go to Northwest, residents in Arizona in the winter go to Northeast, and symmetrically, then we arrive to the different conclusion. And so we see that we have used a clue, we used a semantic property of this table to obtain a better result with respect to the ground truth of the table. So, recently we decided to extend such semantic techniques concerning time. And so we have, here is an example of authors of papers that have moved in the period from 1991 to 2011 and moved in the sense that they changed their university. And we see that the ground truth of this example is that we have 3 clusters of records that refer to 3 different authors. But if we compare the values on time according to high value consistency, we consider this as the measure of the distance, then we see that we have false negatives in our final matching result. On the contrary, if we match records according to their similarity, the similarity of names, we see that in this case we have false positives. So, in order to arrive into a better estimation of the matching between the different records that have been produced, that have been analyzed, that have different timestamps, we see that we can use other clues. And in this case, we are considering two new rules based on the intuition, on the common sense. The first one is that different values over a long time is not a strong indicator of referring to different entities. The second clue, the second rule, is that the same value over a long time is not a strong indicator of referencing to the same entities. We have produced a new technique with researchers of ATT Labs in New Jersey, and the results are promising in the sense that the precision and the recall are improved with respect to traditional products. The second area concerns considering again temporal dimensions, but in another area, in another domain, the domain of quality of data in the web, and especially linked data. And in this case, we know that the amount of linked data in the web is rapidly increasing in time, and the problem is that as more resources and links are added, data consumers have the increasing need to deal with huge and noisy data sets that change dynamically over time. So we decided to look at which are the traditional data quality dimensions and which are the relevant corresponding dimensions in the world of linked data. And we have found that such dimensions are accuracy, are consistency, are completeness, are accessibility, and finally, last but not least, are temporal dimensions. In the following, we will focus mainly on temporal data dimensions, but just to show you an example of another dimension, for instance, concerning completeness, what happens is no semantic data are caught. I mean, looking at an array from the web of data, we expect to retrieve, for instance, RDF content instead of HTML pages, but for some reason this data is missing, and so we have to deal with incompleteness. But now we focus on temporal dimensions, and the typical problem of temporal dimensions and of temporal quality is that is the inclusion of outdated data, as we have seen also in some examples before my talk. I mean, statements recorded, for instance, 1 year ago are considered not valid since they do not match to real world data. So, in order to provide some useful results in this area, we have considered the three most mentioned dimensions in the literature. I mean, timeliness, currency, and volatility. Currency means the age of data, the rapidity, the speed with which a change in the real world is recorded in an update in a database or in linked data. On the contrary, volatility is a mention of the instability of the information, so that how the information changes on time, and evidently is typical of the different attributes that an entity may have as properties. For instance, the date of birth does not change, but on the contrary, the age changes, and so on, of a person. Now, the final goal of our activity is to deal with timeliness. Timeliness that has two components that corresponds to the two dimensions that I mentioned before. Timeliness is defined in the literature as the fact that the process that use data, when they have the need to use such data, find the last version of data, the most current one. In consequence of this, timeliness can be split in two components. From one side, the currency, and from the other side volatility, and so we are looking for methods that, based on the information we get on linked data, make us able to estimate from one side currency, from the other side validity. From this point of view, we have decided to consider an important data source, the so-called Billion Triple Challenge 2010, that is a data set consisting of linked data crawled from the web, that is stored typically in the web as streams. And we are considering three types of information that we meta type information that corresponds to doubling core predicates when they are available, other explored predicates, and finally HTTP header metadata. For each one of these three sources of information, actually, we try to associate the information that is obtained in terms of a meta-time ontology, and the three classes in terms of which we classify such information that comes from HTTP, from doubling core, and from other sources, is in terms of date of modification, date of creation or publication, and finally date of issue. Once we are able to associate, for the moment by hand, but we hope in the future also automatically or semi-automatically, then at this point we are able to make an estimation of, as I said before, of currency. The problem of estimating volatility is much more more complex, and so we will be, I guess, in the near future. Now we move to another area. The area is record linkage techniques. When considered within a new area of research in the web, again, what is called a typical crowdsourcing. We have a big database of patents in which we want to discover, this is an European project, we want to discover which are the duplicates, so we have a problem of deduplication. And this database is very huge, and so there is correspondingly a big problem to evaluate all matching pairs in several millions of records. Traditional techniques, as I've shown before, typically use a distance, glue, temporal validity methods to try to find which are the matching pairs and non-matching pairs. Now we are experimenting a way of adding to these traditional techniques also crowdsourcing based tools for enhancing the disambiguation of data and the effectiveness of the matching method. So users can download, users of this database can download a subset typically of the whole data set, and have consequently in a crowdsourcing strategy region have the possibility to increase the data quality with several heuristics, hand-checking data and survey work on smaller samples, or algorithms that fit better subsample specificities. For instance, it could be that analyzing the distance on the country is more reliable than on other attributes of patents, or accordingly technological field, and so on. And finally are considered also other data sources that on which the specific groups of users can be scaled. These are the different possible heuristics that we add to traditional method in order to enhance record linkage procedure. The final area is quality of data schemas. We have moved from the investigation of quality of data schemas to quality of ontologies. And with Matteo Carbonari, here I cannot say that we made research. We presented a tutorial and a case in 2010, and so in order to prepare such tutorial we have to compare the different proposals, the different methods, both for conceptual schemas and for ontologies. And now I show just 3 or 4 slides that allows us to compare, to understand which are some differences between the two approaches. First of all, the definition of dimensions and metrics, both for data and for conceptual schemas and for ontologies, needs, first of all, a classification proposal, a model of classification. And for instance, this is the classification that is proposed by Gangemi, that uses this 3-level classification, structure of dimension. So the syntax and formal semantics of conceptual schema from one side, ontologies from the other side, the functional dimension, so the intended use of the conceptual schema or of the ontology, and finally the usability profiling dimension. It's easy to understand, it's easy to use, it's easy to read. Gangemi makes another step and produces a meta-ontology of ontologies. So an ontologies that represents ontologies as semiotic objects and the context in which they are used or they are defined. And we may see with different colors inside the meta-ontology proposed by Gangemi, which are the structural dimensions. So you see essentially the structure of the graph that mathematically represents the ontology, the functional dimension, and finally the user profiling dimensions. Once obtained, produced this meta-representation of ontologies, then another proposal by Gangemi et al. Is to provide a certain number of dimensions and subdimensions and also metrics that correspond to structural, functional, and usability profile. There is a difference, probably you know, between dimension and metrics. Metrics provide a method that allows you to associate a quantitative value to the dimension, and you see, for instance, number of parent classes, number of children classes, or else go into usability profile recognition, the documentation that is available, and so on and so on and so on. Now, just to show you an example of dimension that is typically proposed for conceptual schemas, I'll show you these 2 schemas that represent exactly the same reality, the reality of a company that sells products, and just looking at the 2 graphical representations of schemas, conceptual diagram, I guess we can arrive to the conclusion that in order to read, in order to be able to understand, which is the meaning of the conceptual schema, the right-hand side, just 2 minutes, the right-hand side schema is more readable than the left-hand side, since it respects several aesthetic criteria. Although 20 years ago I went to China, invited by the World Bank, and I have shown these 2 similar to these diagrams to Chinese professors and Chinese students, and they said, why you say that the right-hand one is more readable? For us it's more readable, it's more understandable, is aesthetically better, the left-hand one. And the left-hand one, since it has some movement. On the contrary, the scheme on the right-hand side is very static. So you see that a lot of aspects that we can consider universal depends deeply on the culture of the people. Okay, moving to ontologies. This is another conceptualization of the different types of qualities that can be defined for ontologies. Now, I don't have time to explain all these different aspects, but I like to focus on the type of quality that is mentioned in the left bottom part of the diagram, process task. Process task quality means that the conceptual model, the ontology, is useful with respect to a process task that is used in practice. And from this point of view, now moving to this slide that can be considered the last one of my talk, you see that we can arrive to the conclusion that process task related qualities of the conceptual schemas and ontologies are probably of low relevance in conceptual schemas. This is the difference between the two fields, and are low relevance for conceptual schemas since they are used essentially for database or information system design, while on the contrary, it's shown several different applications of ontologies in which ontologies can be used effectively as a high relevance for ontologies during, as I say, to exploitation of ontologies in different applications. This is the slide.
Thank you, Carlo. Question?
Hi. I just want to ask, where did you reach on 1 billion triple challenge? And is it open for public, or is it for special use?
No, it's open for public.
Where did it reach? How many triples are collected until now?
Oh, I don't remember now, but it's about hundreds of millions. This is the order of magnitude. Yes.
So, other questions? Well, I personally have a question, but I would like to move to maybe break or later, and now go to the online with Egypt. Do you hear us, Dr. Mohsen?
Yes, I hear you.
Okay. I'm sorry, maybe you cannot see us. The camera is not. You have camera. So maybe you can even see us. So let me introduce Professor Mohsen from RDI. Professor Mohsen Rashwan is actually having a company now, very interesting company, one famous in the Arab countries. It's called RDI, working with the natural language processing and a lot of language technologies. And they have very interesting lexical database. And Professor Rashwan is associate partner in the Sierra project. So there we have core partners and associate partners. The core partners, as you know, I introduced in the morning, are University of Lisbon and University of Trento in Italy, University of Milano Bicocca, and we have Princeton University, or through, let's say, the Berlin Academy of Sciences. The associate partners until the moment are RDI, and we have Vrije Universiteit Amsterdam, and we have also our Ministry of Telecommunication, and we have our Cultural Heritage Organization from Bethlehem. They are also going to present some work today. So I will leave you now, Professor Rashwan, to speak about the lexical resources at RDI.
Okay, my voice is clear?
Antonio, let's go, speak us a little down. Okay, please try again.
Oh, okay.
Perfect.
Welcome everyone. Just to introduce myself, I'm Professor Ashwan from Cairo University, and we have worked in the university as we have commercial work in the company RDI. The website of RDI is below the first slide. I'm going to represent, concentrate indeed on the part of what we are doing in RDI. We have a complete suite for Arabic language technology, including Arabic OCR, Arabic text-to-speech, Arabic speech recognition, search engine, morphological analyzer, automatic differentiation. So we have a complete suite for Arabic technology. And from a few years, we started working on building our own Arabic lexical semantic database. This is what we are going to go through in these minutes. The PowerPoint doesn't, Mr. Anton, the PowerPoint does not flip.
I think the problem is from your side, maybe.
Let me check again. I worked with it.
Try stop it and another time try sharing.
Okay. Stop sharing now?
Yeah, stop sharing and then try another time.
Okay.
Yeah.
Okay.
Yeah. Can you try now? Fine.
Just a second. Okay.
Share my desktop. It's in the middle.
Just a second, because I don't know why I didn't have the. I have to start from the. Okay, I have to start again from the mail.
No, not from the mail. Only from the bottom. The bottom inside, in the middle of the screen.
I cannot see it now. It disappeared.
Okay. Okay, I will follow up with you. I have your presentation on my laptop, and I will follow up with you. You can just start, proceed, and I will follow up with the presentation. Does this sound good?
Okay.
Okay.
Well, I prefer to just a second. Give me a few seconds till I can enter again, because I do. I think I have little adjustment for the. I think I'm in now. Just a second. But one second. It is. I think it is working now. Okay. I will.
You logged in again. Now I have a second. Okay. Try to share now.
Okay. You see me now?
No. I must pass you the role of presenter another time. Okay. Another time. Now.
Okay.
Try now. Okay.
Now?
Yes. Just a moment. Just a moment. Okay.
So that point is on now?
Yeah, okay. Yes.
Let me see. Oh, okay.
No, just,
So, to go quickly on what we have done, there is one echo. Can you stop the echo?
there is what?
And the voice.
Just a minute. Okay.
Okay.
Now.
Okay.
Okay.
We started working on this data. There is heavy feedback. With 2005 until 2009, based on the concept of semantic field, we had to base our work on what is called large thesaurus المكنز الكبير for Dr. Ahmed Omar. It contained about 2,000 concepts. We have divided it and reached to about 18.4 thousand fields. Field is very close to the concept in the word net, and we have about 100,000 entries with about a little less than 300,000 relations. The tools that we have used, the Arabic morphological analyzer of RTI, we have built a general concept tree, and we also have some other semantic tools. Yeah. I think you should use your PowerPoint presentation.
just close the sharing on your side, and I will use my PowerPoint.
Okay. So I am in the third page or third slide.
Third slide, okay. Yes, we are hearing you. Hello?
Okay. So the importance, of course, the lexical semantic database has a lot of uses. It could be a good base for building an Arabic content. You can use it semantic analyzers, distribution tools, semantic search engine, machine translation systems, etc. How we design it? We did it on. We started from the Arabic characteristics. We respected the Arabic characteristics. I mean, in the WordNet, it is divided into names, verbs, adverbs, and adjectives. From our point of view, this division is not valid for the Arabic. However, we have built it a little different than the WordNet. We have used the original work of the large thesaurus of Dr. Ahmed Omar and the other mythological analyzer. The coverage, we believe that it has good coverage for the classical art and good coverage for the MSA, but the MSA needs some more work. Okay, and it is not, we have also built a website to collect the annotations because the work started from thesaurus, and we have worked with a lot of these thesaurus and put it in a very nice state. However, to make good coverage for the modern Arabic, we need to collect corpus, new domain or something similar, and we should annotate semantically all the words of this corpus, and then we can update our digital database. We have done the first part, which is organizing and enhancing the what we call it the large thesaurus. But the second part, we have to collect the data and build the site and then atomize. We started by about 1800, what we call the large sort of mean general concept. We have taken part all the words and morphologically analyzed all words. So I am listening with the slides. Are you saying?
Yeah.
And the construction is here now.
Slide 4.
Number 6.
Okay, yes.
Oh, sorry. Because it is in front of me, I couldn't. Okay. So we started by 36,000 words. We added to these words many things. We added the broken dollar. In Arabic, it is a must, and it is, you have to add it by hand. And we have added also some named entities. We have also increased these entries to about 100,000 now. So we have, and we put it in a relational database, well-structured database. We have, as I said, for about 300,000 semantic relations. We have about 19 semantic relations under 4 large criteria: antonymy, semantic relations, general and particular, cause and effect, time and place. Next slide, please. We have used the morphological analyzer to analyze each word. As you can see, these are examples of morphologically analyzed words. In Arabic, we separate prefix, suffix, root, and pattern. Next slide, please. We add also part of speech tagging to each word. As you can see here, we define each word by the part of speech tagging. For example, the word kana, the first example. The fifth is conjunction haraf. We ma is a noun, and this description describes all the features of the text that is relevant and describe the word. Next slide, please. We have organized this data in what we call forward Arabic digital semantic RDB. Here, an example of physical compound. The physical compound is one or two words that describe certain concepts. All these words is included in a single semantic field. Okay. Second slide, please. What we call the backward Arabic lexical semantic RDB. Here, the entry is the word, and each word can lie in more than a semantic field. As you can see, we have the word kataba, the first word kataba. It is included in 6 different semantic fields. I don't know if it is clear or not, but at the right-hand side, it can be investment, it can be contracts, can be correspondence, can be authoring, writing, and so on. Is it clear?
Is it clear?
Yes. Okay. Next slide, please. These are examples of some of the semantic regulations, like the economy and the line, and so on. This I think clear. The second slide, or the following slide. This is an example of another relation. As you can see, and the right-hand side is ala, which is a tool or an instrument, and the examples of this tool or an instrument. Okay. The following slide, please. This is also another example. Okay. 14, number 14, number 15. So, number 15 now. So, what we have started with the, as I said before, large thesaurus. When we use it and put it in machine readable format, we find that it includes, it is not complete. So we completed it and we reorganized it in a way that could be make the use much easier. He put many words, just the meaning you can catch, but it could be different topics. It could be there is a lot of differences in the use, so we have to reorganize it, and we divided each semantic field into 3 or 4 semantic fields, so that we end up to even more. We end up to about 18,000 semantic fields. Next slide, please. This is an example of semantic field called authoring, and you can find some words, ألف, تأليف, مؤلف. The following slide, please, number 17. This is an example of the new division. So we have to choose the word that's consistent with the more concise semantic field that we end up. Number 18, slide number 18. Let me jump it to. Now we discover that we need to build a concept tree. So we have used many sources, as you can see, to build something like 5,000 that represent a tree with all the levels, using the economy and the general and the specific concepts and something like that to build like a tree. It is very important in some applications. The following slide, please. This shows the depths that we have done through about 9 different levels. And after the following slide, please. We plan, and we have already collected 10 million words of modern standard Arabic, basically news domain, and they can easily morphologically analyze automatically, but we need to revise this by hand because we get accuracy in the range of 95–96%, and if we need to complete it to 100%, we have to pass by the human. Okay, next slide, please. So after making the annotation by morphological and semantically, then we can update our concepts and our trees. To do that, we discovered that this is very costly, so we developed our site application for to make sharing from the students, from the general or the public, to help in doing that. And it is based on a very dedicated, we test and give degree for the accuracy for each annotator, and we can discuss or can give high sort of acceptance for the good one. Next slide, please. This is the website interface. It verifies because the words are in the other row, and each word we generate from the lexical database from sentences that's available, and once you click on the sense, it's accepted. And you can, if the sense is not existing, you can add it by hand to make it easy. The next slide, please. This the workflow, how to examine and how to do our work on the corpus. Next slide, please. Because simply, we have to, what's remaining to do that is to, again, annotate the 10 million words and escape and fill the gaps. And then we use the RTI dictionary that describes each entry. We can also collect examples from the corpus with each entry. Then relating it to the word net would not be a difficult job by making some translations. And thank you. This concludes my
Okay. Professor Mohsen. So now we ask there's questions, quick questions, please, because we are late.
I just want to ask about
The voice is not clear.
I will.
part of speech tagger. How good is it? What's the level of accuracy in your parts of speech tagger? And does it supply the functional words for مبتدأ خبر وفعل وفاعل, subject, predicate, and object? The accuracy of the tagger, part of speech tagger.
The accuracy of the part of speech tagger. Can you please comment on this?
Okay. Our part of speech tagger, we have master degree in comparing it with Dr. Bonatia. It turns out that if we use database very close from Monadiab data, Monadiab gives in the range of 95-96% accuracy, and ours gives in the range of 92-93. When we use data that is more close to ours, our morphological knowledge gives something like 96 and sometimes 97%, and Monadiab speech tagging gives in the range of 89-90%. All in all, we have like 1% accuracy more than, because we use data for testing, database, collected database from LDC and from the kind of data that we worked on. So it turns out we have like 1%, but it's very dependent on the data that you are using. And you can increase the accuracy if you adapt it or use some of the training data from the same domain. But in the range of 95%, or let me put it from 92 to 97%. It depends on the exact source of the data you are testing.
Okay, there is another question. Come here.
Ma'athir Alqam, student at Birzeit University. Is there a semantic relation between the semantic fields?
Can you repeat the question, please?
Is there a semantic relation between the semantic fields?
So she's asking about the semantic relations between the semantic fields. I also share this view because I see there is homonomy, but I mean, what kind of also semantics of this?
I give you an example. In one semantic field, he can note, for example, Dor al-Ibadah, the worshipping houses. He can note Masjid, جامع, كنيسة, صومعة. But when we try to divide it into smaller semantic fields, we collected جامع with masjid and we separated from كنيسة. You have something, for example, another semantic field, we collected جاسوس, جاسوسية, مخبر, مخابرات, something like that. But we separate things, and when we treated it, we re-annotate it and collect the things that is more similar to each other. So it's a wide range of collection. You can refer to Dr. Ahmed Mukhtar Omar he had some about semantic fields.
Is it the same, because what's it? Is it the same as, I mean, semantic field, is it the same as sense awareness?
We started with something much wider than that, but we ended up to something closer to that. We take each large semantic field and divide it into much more close meaning, so it approaches the concept.
I wonder if can we have an access to your database for research purposes?
Okay, we can talk with each other. It is not until now public, but we many researchers we have give them a copy to work with. I mean, we have many of the students around us who can apply or we can organize with their supervisors to give them a copy for research purposes.
Professor Rashwan, if you allow me, this is Mustafa. Actually, I have a question, if you allow me. Why you said you have only almost 18,000 semantic fields? I mean, but there are much more in, I mean, in any language. I mean, like for example, in Word, the common sense or the Word is 117,000 senses. Why Arabic or why your database only 18,000?
This represents the core of the language. It doesn't contain named entities. With this that start, we consider the database of the large scholars of Dr. Ahmed Turan, the good start. They have spent like 5-6 years building it, and this is what was available. The best that was available in Arabic when we started, and we built on that. We organized it. We added many words to it. We can continue or separate the large concepts. So it depends on the granularity you are going to serve. I'm not exercised to go to very fine granularity because it turns out in many applications that uses the word net that it can make noise more than it can help. So keeping the larger granularity might be useful in many applications.
Okay, let me thank you again. Actually, let me announce another thing in our project because we are now associate partners, and because you cannot come to Palestine or your team also. Actually, we have a budget to visit you and to send some students to your
I cannot hear, especially the budget.
So I mean, I'm speaking in English. So I mean, because you cannot come to Palestine for political reasons, it means that during this project we will visit you. So we will send some students and researchers to your company to to build closer collaboration and to understand your database more.
Yeah, sure.
Okay, thank you again. Bye bye.
Thank you so much.
Now.